We will measure the distribution of these galaxies to try to constrain the physics of dark matter and dark energy and hopefully find some crack in the theory or something that we can probe deeper into in the future.
Euclid is a space telescope, ready for its journey into space. It will scan the sky, mapping the whole universe, showing the unprecedented huge amount of galaxies, and bringing light to dark matter and dark energy. It will reconstruct 10 billion years of cosmic history. Euclid is an ESA mission. UZH scientists are part of the Science Working Group.
My involvement in Euclid is in one of the science working groups of Euclid, called the Simulation Science Working Group. And as the name suggests, I'm mostly involved with numerical simulations of the universe. My name is Joachim Stadel. I'm a professor of computational cosmology at the Institute for Computational Science here at the University of Zurich. And my function is both teaching and research. So a big part of my research is involved in Euclid. We run a computer simulation which tells us how all of the things are distributed in the universe. And this can be compared to data, but it can also, before Euclid launches, be used a lot to calibrate the measurement methods that Euclid will use. The universe is very large, and on these very large scales, everything moves according to gravity. So if we look at the universe and we look at how the galaxies are moving, they're moving away, they're expanding, the whole universe is expanding. And how fast or slow it's expanding is dictated by Einstein's equations. So since about 1960, galaxies have been observed, and in particular how fast they are rotating has been observed very precisely. And it's been known for a long time that these galaxies are rotating too quickly to be held together by just the mass that we see in stars and gas. That's not enough to hold them together if they're rotating at that speed. And so dark matter was proposed to solve this problem. The little video clip is a simulated galaxy, and in one case it's rotating the way it would if there was only the mass of the stars and gas in that galaxy, what we call the visible mass. On the other side, you have the galaxy as it rotates with dark matter included. And that rotation is what we observe in all of the galaxies that we have looked at. So there is dark matter in almost all galaxies that we know, and it also is connecting the universe in a kind of a structure that we call the cosmic web. And more recently, it has also been seen that dark matter is absolutely needed to explain the microwave background radiation of the universe. So there is some kind of material that we don't know what it is, and beyond that, we also have something called dark energy. And dark energy actually dominates this expansion that I mentioned. Dark energy is still a complete mystery, and Euclid will probe this dark energy. It'll be a very precise probe of this dark energy. The universe is predominantly, in terms of mass energies, made of dark energy, about 68 to 70% of dark energy. Then the next biggest component is dark matter. And then a small sliver is actually made of normal matter that we know. Protons and neutrons, hydrogen, helium, everything that normal materials that we know of. That makes up only 4% of the universe. Most of what the universe is made of we don't see, and in fact we don't understand yet completely. We know it's there. We have a very precise measure of how much of it there is, but yet at the same time we have a quandary because we don't know what it is.
Euclid will be launched in July 2023 and travel to its destination, the Sun-Earth Lagrange Point 2, 1.5 million kilometers away from Earth. The first raw data from Euclid is expected to be available in 2024.